Yeah, so let's get started then with the last presentation of the day. Good afternoon, everyone. My name is Rodrigo Andrew. Good. So just then to continue then. So I've joined CST in 2013. Today I am a senior industry process consultant for life science and high-tech industries here in Eurocentral. Today the topic that I want to present to you is Antenna Radome Design. So let's jump right into it because, yeah, time is short here for today. So when you think about radomes, I think classically one would think about an aircraft, right? So in a broader sense of the word, a radome would be any structure that protects the antenna and the electronics inside of eight of the enclosure in there from the environment. And if we take a look at the aircraft in here, the radome shown here in this green hue protects a wide range of antennas in there, from the radar systems on the tip of the aircraft, the GPS systems here on the top, to the EME system on the bottom of the aircraft here, just to name a few. But as we have seen throughout the day, radomes are not just used in the aerospace industry, but also, yeah, to protect the array inside of the base station that we have shown in the array design workshop or presentation, and more recently now with Jan with the automotive radar. Good, but as we start to introduce and enable 5G communication with the millimeter wave range here for the consumer electronics, I would say that the radome design is making its way also for the common goods that we can get, so consumer electronics. Here we just see two examples of internal projects that we had here in Dassault, where I had the opportunity actually to work with them. And my task was to provide a millimeter wave connectivity for a mobile phone, and also a DBIMI here, a home projector in there. And well, let's say I had the chance here to study pretty much and what are the design challenges that such industry now here would face when designing the covers, or let's say the radomes for that matter, right? So what is the reason why when we talk about consumer electronics in the millimeter wave range here, the plug-and-play philosophy would not work anymore? So we could think about taking an antenna, put inside of our phone, of our smart projector in there, and then we will have there our S parameters, our radiation pattern, and then we just need to make a small tweaks in there to the antenna to make them perform better for what we want. And the chart already tells you a little bit the story, right? So dielectrics do have a transmission profile which looks like this wavy waveform, this wavy curve in here, where we have optimum points of transmission. If we take a standard ABS plastic here, which has 2 millimeters of thickness, which was one that came with one of the projects in there, we see that when we make this transition mapping here, it just